Continuing 2.3 higher degree polynomials. This starts with number 5. I'll work for about 10 minutes or so and then end this video and make as many as I need. We're working on higher degree polynomials, second, third, fourth degree. If we look at number 5, it says graph the function in a viewing window that shows its extrema. Remember, extrema is just a plural word for minimums and maximums. And we also want to find the x-intercepts. X-intercepts, remember, are the y-coordinates where the graph crosses the x-axis. So extrema, notes for people that aren't watching the video, are maximum and minimum. If they want extreme values, then you're going to give me the y-coordinates. So hopefully it fits. X-intercepts, I want the x-coordinate. When the y value is 0, or the x-coordinate where the graph crosses the x-axis. So you graph the function, you pop it in Desmos, you put in this entire function. Now we know, before we even put it in Desmos, let's switch colors here. We know that this is fourth degree, which means we're going to have this U shape, or it's going to be, have some extra action happening between the ends. But we know it's going to be a U shape, and because this is a positive leading coefficient, we know that it opens up. So we can use process of elimination, and we can eliminate these ones that are opening down. We know it's not C, we know it's not D. So using the information from the leading coefficient and the degree. Then, once you figure out which graph it is, then you're just going to look at the graph, and this notation here now popping in. Remember, this is the x-coordinate. The limit as x approaches infinity is the x-coordinate, and it's going to get positive and a really big. That's what infinity means, which means we're really just looking at the far right side of the graph. And then the number, how do I do this? I guess this answer that you're plugging in here is the y-coordinate on the right side, the far right side of the graph. So x-coordinate, it's got an x pointing at a number. Y-coordinate is the number that goes in the blank on the right side of your equal sign. Once you get that down, limit notation isn't so bad. When we look at the next one down here, now this x is negative, which means we're looking at the left side of the graph. And you're going to give me the y-coordinate in here. I think that's all the hint you need on that one. Number 6, we want to approximate, which means we get to use a decimal. We want real zeros, which means no imaginary numbers. Zeros are the y-coordinate. No, they're not. Let's back that up. Zeros are the x-coordinate when the y is 0, or visually, it's the x-coordinate where the graph crosses the x-axis. So, using what we know about the degree, let's switch colors here. My degree for this function is 3. My leading coefficient is a positive. So I have a third degree positive leading coefficient, which means my graph should have a shape that looks like that. It should move up towards the right, which means using that information, I know it's not A, and I know it's not B, so it's either C or D. When I trace from left to right, it has to have some kind of shape that moves from the left to the right. So if I look at C, it goes up. As I get over to the right side, I'm going up high. Same thing on D. I start down low on the left, and as I move over to the right, it goes way up high on the right side. So you get to pick the graph, and then we got our little approximately sign, and make sure that you read these directions. It's going to tell you where to round off to. It says round to 1 decimal place as needed. This is different for every problem, so you want to read this very carefully on every single problem. So you can pull that off of Desmos set. Oh, I should make a note here real quick. Use Desmos. All right, that's number 6. Number 7, more graphing. Again, I'm thinking Desmos here. Oh, yep, we have approximately symbols. I'm gonna go now. See, this one says round to 2 decimal places, so you have to read this really carefully, because I think different people write these, so you just have to read the directions for every single problem. Oops, not the page. There we go. Using what we know, we have our degree. We're going to look at our leading coefficient. We're going to get a picture of the shape. Once we know the shape, so then we're going to be able to eliminate some of the answers. How many can we eliminate? We got 4th degree, opening it up, so we're going to be able to eliminate 2 choices. Not going to tell you which one, you can figure that out. Then you're going to graph it, and again on these graphing ones, I should have mentioned this on the last problem. Notice when they do these, on all your answer choices, the X values are the same, so you want to set your window to match what's happening on your answer choices. So I'm going to set my X's from -2 to 2 in that little wrench in the top right corner of Desmos, and then I'm going to set my Y coordinates. Notice on all of my answer choices, my Y coordinates are the same. So I'm going to set my Y coordinates to go from -20 to +50, and that's going to make it real easy to see for sure which graph I want to select for my answer. Number 8 says find the zeros of the function algebraically. Ooh, yay, algebra. That means do not use Desmos. So algebraically, we're going to try some factoring. So if I'm looking for zeros, I want the function value to be 0. We're going to go 0 equals 10r squared plus 33r minus 7. We're going to set up some parentheses maybe. And I could go 10r and 1r. Or I'm not going to do this for you. I'm just going to give you some choices here. I could go 5r and 2r. I know my signs because I have this negative here. I'm going to go positive, negative, or negative, positive, depending. So you're going to do some guess and check. And then always read this. Type an integer or simplified fraction. But then, right here, if you're going to enter more than one answer, you want to use this comma to separate your answers. All right, let's look at number 10. A lot of times it's the input that gets people, so always keep reading that on your screen. It looks like a little blue set of text there. Always read that with this program. Number 9, state the degree and list the zeros of the polynomial function. So I'm going to underline, I'll highlight because I can. I want the degree. I want to list the zeros. I want to state the multiplicity, that's new, of each zero and whether or not the graph crosses the x-axis at the intercepts. So there is a video posted that explains multiplicity. Let's talk multiplicity for a second though. If I have a power on a factor greater than 1, then, well, let's see, go here. This one, the multiplicity is 1, which we usually don't write, multiplicity of 1, because that's just too much extra work. But when I get to this other one where I have this squared, that power is your multiplicity. See how we like to use the word multiply because we're math people? So multiplicity is 2, whatever the power is on a factor. Remember, the factor is in parentheses. Whatever the power is on that factor, that's going to be your multiplicity. Notice also in this one, as you start working the problem, they're going to want you to list these in order. Or when you enter them into MathXL, they'll probably mark them wrong, okay? And again, here we're going from the right, so make sure you watch the order really carefully as you're entering these. Once you have your, so the degree of this function, when you have factors listed, you're going to add the powers on all of the factors. Even if the one isn't written. Wow, I don't know what that was all about. Sorry, hope I didn't make you dizzy. Even if there's a power of 1, it's not written usually, we're still going to add it up. So the degree of this polynomial, this particular example, is going to be the 1 plus the 2. So we have a third degree polynomial that we're looking for. And our leading coefficient, if we want to use that to help us, you're going to take the coefficient of each x term in the factors and multiply. That's kind of weird. Let's see if an example makes it a little more clear. So in our problem, we have x times x minus 4 squared. Oops, pencil. X times x minus 4 squared. So we're going to take this x, there's a 1 here, times the 1 inside in front of that x, and that 1 inside is being squared. So my leading coefficient is 1 for this particular problem. And it's positive. That's really the important part. All right, and then you can have a graph that crosses the x-axis or bounces off. If does not cross, means it bounces. Off the x-axis. So, like right here, that's a bounce. It does not cross. All right, how are we doing here? Let's see what number 10 is all about. Number 10, I don't think you need anything new. That's a replay of what you've been doing. Make sure that you're reading this stuff down here closely. Before you put your answers in. And here's another one. We're going to separate commas if we need to. This, maybe I do need notes. This notation right here means my x minimum is -4, my x max when I go to set up my Desmos window. My x's are going to go like this. And my y's over here, this is my y's. I'm giving the y min because if you have a graphing calculator, they're going to word them as y min, y max. But in Desmos, when you set your window, you're going to grab that line up in the little wrench and you're going to change your y's to go from -24 to 24. And then your graph will match. They'll be the same size, so you'll be able to select your choice pretty easily. All right, that's it for, I guess we did 5 through 10. I'll make another video for the rest.